What if I told you that the James Webb Space Telescope has just shattered one of the most fundamental assumptions about our universe? Not just tweaked it, not just refined it, but completely obliterated it. And what it found when it looked deeper into space than we ever have before is so shocking that it's forcing us to rewrite cosmology textbooks. Picture this. On July 12, 2022, NASA released the first deep field image from James Webb. Scientists expected to see ancient, primitive galaxies, the cosmic equivalent of cave paintings. Instead, they found something that shouldn't exist. Massive, fully formed spiral galaxies with intricate structures, existing just 400 million years after the Big Bang. These weren't supposed to be there. It's like finding a Ferrari in a Stone Age cave. Dr. Joel Leah from Penn State University put it perfectly when he said these observations are bananas, his actual scientific quote. These galaxies are so massive and so well developed that they challenge our entire understanding of how the universe formed. We're not just talking about being a little off in our calculations. We're talking about discovering that everything we thought we knew about cosmic evolution might be fundamentally wrong. But here's the truly mind-blowing part. This is just the beginning. What James Webb found gets stranger, more impossible, and more reality-shattering the deeper we dive. By the end of this journey, you'll understand why some of the world's leading cosmologists are saying we might be living in a completely different universe than we thought. If you're ready to have your understanding of reality fundamentally challenged, hit that like button right now. And in the comments, tell me what country you're watching from and what time it is where you are. I want to see how this cosmic revelation is spreading across our planet in real time. Don't forget to subscribe, because we're about to embark on the most mind-bending journey through space and time you've ever taken. Before we dive into what's breaking physics, let's establish what we thought we knew about our universe. Think of it like this. Imagine the universe is a city being built from the ground up. According to our best theories, it should start with simple shacks and slowly develop into skyscrapers over billions of years. The standard model of cosmology tells us that after the Big Bang, the universe was essentially a hot, dense soup of particles. No stars, no galaxies, certainly no complex structures. For the first 400 million years, what we call the cosmic dark ages, the universe was literally dark. No light sources existed except for the fading afterglow of the Big Bang itself. Here's where it gets interesting, and where our first surprise begins to emerge. Dr. Volker Braun from the University of Texas spent decades modeling how the first stars should form. According to his calculations, these population 3 stars should be massive, short-lived, and create the heavy elements needed for later generations of stars. It's like cosmic recycling. Each generation builds on the debris of the last. Think of it like making a cake. You need ingredients first: flour, eggs, sugar. In space, you need heavy elements like carbon, oxygen, and iron to make planets and complex structures. These elements didn't exist at the beginning. They had to be cooked inside the cores of massive stars and scattered when those stars exploded as supernova. So the timeline should go like this: Big Bang, Dark Ages, first simple stars, first simple galaxies, gradual building of complexity over billions of years. By the time we're looking at light that traveled for 13 billion years to reach us, we should see the universe's baby photos: simple, primitive, underdeveloped. But here's what will blow your mind. James Webb isn't seeing baby photos. It's seeing graduation portraits. Dr. Garth Illingworth from UC Santa Cruz, who has spent 40 years studying galaxy formation, looked at the first James Webb images and said something remarkable. We're seeing things we never expected to see. The Hubble Space Telescope gave us incredible views, but it was like looking at the universe through foggy glasses. Think of it like trying to see through water. You get the general shapes, but the details are blurred. James Webb, with its massive 6.5-meter mirror and infrared capabilities, is like suddenly putting on perfect glasses and realizing the blurry shape you thought was a bush is actually a detailed sculpture. And that's when everything started falling apart in the best possible way. Because what James Webb revealed wasn't just clearer pictures of what we expected. It revealed that our expectations were completely wrong. Now we're going to talk about something that's breaking the brains of astronomers worldwide. Remember how I said James Webb found fully formed galaxies where there should only be simple structures? Let me show you just how impossible this really is. Dr. Ivo Laub and his team at Swinburne University made a discovery that sent shockwaves through the scientific community. They found a galaxy called Galaxy 13, existing when the universe was only 325 million years old. But here's the kicker. This galaxy has a mass equivalent to 1 billion suns. To put this in perspective, that's like finding a full-grown oak tree in a field where you planted seeds yesterday. Think of it like this. Imagine you're watching a time-lapse video of a city being built. You expect to see the first few frames showing construction workers laying foundations. Instead, the very first frame shows completed skyscrapers with working elevators and Wi-Fi. That's essentially what we're seeing with these early galaxies. But it gets even more mind-bending. These aren't just large, they're organized. They have spiral arms, central bulges, and complex structures that should have taken billions of years to develop. Dr. Erica Nelson from the University of Colorado looked at these images and said, "The models just don't predict this. We're seeing things that are way too big, way too early." Here's what should blow your mind. The math literally doesn't work. According to our current understanding of physics, there simply wasn't enough time for these massive structures to form. It's not like being off by a little bit. It's like calculating that a journey should take 10 hours and arriving in 1 hour while going the speed limit. Let me break this down with an analogy everyone can understand. Think of galaxy formation like growing a pearl. You start with a tiny grain of sand, and layer by layer, over long periods of time, you build up this beautiful, complex structure. What James Webb found is equivalent to opening an oyster that was born yesterday and finding a fully formed pearl the size of a baseball. The most shocking example is a galaxy dubbed Maisie's Galaxy, named after astronomer Stephen Finkelstein's daughter. This galaxy appears to exist when the universe was only 390 million years old, but it's already undergone multiple generations of star formation. That means it had to form, create stars, have those stars live their entire lives and die, create new elements, form new stars from those elements, and repeat this process multiple times, all in less than 400 million years. To understand how impossible this is, consider that our own Milky Way galaxy took over 10 billion years to develop its current structure. These James Webb galaxies did something similar in less than 4% of that time. It's like watching someone build the Empire State Building in a weekend using only hand tools. Dr. Casey Popovich from Texas A&M University put it perfectly. It's like the universe hit the fast-forward button, but we don't know where the remote control is. And here's the thing that will keep you up at night. If these galaxies can form this fast, this early, what else are we completely wrong about? Just when you think the James Webb revelations can't get more shocking, we need to talk about what astronomers are calling the red monsters. And trust me, the name is perfectly chosen, because these cosmic beasts are rewriting the rules of physics in ways that are truly monstrous. Dr. Mengyun Zhao from the University of Geneva led a team that discovered something absolutely mind-blowing. They found 3 ultramassive galaxies that existed when the universe was only 600 to 800 million years old. But here's what makes them monsters. They're so red in James Webb's infrared vision that they appear to be incredibly dusty and filled with old stars. Think of it like this. Imagine you're an archaeologist and you dig down to what should be the oldest layer of human civilization, expecting to find simple stone tools. Instead, you find a fully equipped modern factory, complete with assembly lines and computers, but it's covered in centuries of dust. That's essentially what these red monsters represent. The problem is fundamental to everything we understand about cosmic evolution. Dr. Pascal Oesch from the University of Geneva explains it this way. These galaxies are like finding a 50-year-old person in a nursery school. They simply shouldn't exist where and when we're seeing them. Here's what will absolutely blow your mind about these red monsters. The dust we're seeing requires generations of stars to have lived and died. Think of cosmic dust like the ashes from a campfire. You can't have ashes without first having burned a lot of wood. In space, you can't have dust without having had many generations of massive stars live their lives, create heavy elements, and explode as supernova. But according to our timeline, these galaxies are showing us dust and old stars when the universe was supposedly still in its infancy. It's like carbon dating a fossil and finding out it's older than the Earth itself. The math just doesn't work. Dr. Ivo Lab, who's been studying early galaxy formation for decades, made a stunning statement when he saw these results. Either our understanding of galaxy formation is completely wrong, or we need to rewrite the physics of star formation itself. Let that sink in. We're not talking about minor adjustments to our theories. We're talking about the possibility that fundamental physics might work differently than we thought. The most shocking red monster is designated Jade's GCZ130. This galaxy appears to have a mass of nearly 100 billion solar masses. That's roughly the same as our entire Milky Way galaxy, but it exists when the universe was only 650 million years old. To put this in perspective, if the universe's current age of 13.8 billion years was compressed into a single year, this galaxy would be fully mature by January 17th. But here's the part that's keeping cosmologists awake at night. These red monsters aren't just big. They're efficiently forming stars at rates that should be impossible. They're converting gas into stars so quickly that they should have consumed all their raw materials and shut down star formation entirely. Yet they're still actively growing. Think of it like finding a restaurant that's somehow serving 10,000 meals per day, while only receiving enough ingredients for 100 meals. The conservation of mass and energy says this should be impossible, yet here we are, staring at the evidence. And here's the twist that will completely reshape how you think about our place in the universe. If galaxies could form this efficiently, this early, then the universe might be absolutely teeming with complex structures and potentially habitable worlds far earlier than we ever imagined. We're not just looking at impossible galaxies. We're looking at a universe that might have been ready for life billions of years earlier than we thought possible. Now we're going to dive into something that's not just challenging our understanding, it's completely obliterating it. James Webb has discovered supermassive black holes that are so large, so early, that they represent what might be the greatest paradox in modern astrophysics. Dr. Rebecca Larson from the University of Texas at Austin made a discovery that sent shockwaves through the scientific community. She found active supermassive black holes existing when the universe was only 570 million years old. But here's the mind-blowing part. These black holes have masses equivalent to millions of suns, and they're actively feeding on surrounding matter at incredible rates. Think of it like this. Imagine you plant an acorn today, and tomorrow you find a 200-foot oak tree in your backyard, not just fully grown, but surrounded by a massive ecosystem of other plants and animals that depend on it. That's essentially what we're seeing with these early supermassive black holes. The problem is so fundamental that it's questioning the basic laws of physics. Dr. Premature Natarajan from Yale University, one of the world's leading experts on black hole formation, put it perfectly. These black holes are like finding a 300-pound newborn baby. The growth rate required to reach these masses is physically impossible, according to everything we know. Here's what will absolutely blow your mind about how black holes are supposed to grow. When a black hole feeds on matter, that matter gets incredibly hot as it spirals inward. We're talking millions of degrees. This creates intense radiation that actually pushes away new material. limiting how fast the black hole can grow. It's called the Eddington limit, and it's like having a cosmic speed limit that prevents black holes from growing too quickly. But these James Webb black holes seem to be completely ignoring this speed limit. They're growing at rates that are 5 to 10 times faster than should be physically possible. Dr. Fabio Pacucci from Harvard University calculated that for these black holes to reach their observed masses, they would have had to be feeding continuously at maximum capacity since the moment the first stars formed. That's like finding someone who's eaten every single meal at maximum speed since the day they were born. The most shocking example is a black hole in the galaxy CERS 1019. This monster has a mass of about 9 million suns and exists when the universe was only 570 million years old. To put this in perspective, our own Milky Way's central black hole, Sagittarius A*, has a mass of about 4 million suns, and it had 13.8 billion years to grow to that size. But here's where it gets truly mind-bending. These aren't just massive black holes sitting quietly in space. They're quasars, some of the most energetic objects in the universe. They're actively consuming matter and shooting out jets of material at nearly the speed of light. Think of them like cosmic lighthouses, so bright they can be seen across the entire observable universe. Dr. Xiuhu Fan from the University of Arizona discovered something even more impossible. He found quasars that are so luminous, so early, that their host galaxies should have been completely sterilized by the radiation. It's like finding a thriving garden right next to a nuclear reactor that's been running at full power. Here's the paradox that's breaking physics. These supermassive black holes need to exist, early to explain what we're seeing, but they also need the galaxies around them to form stars and feed them. It's a chicken and egg problem on a cosmic scale. Which came first, the massive galaxies that could feed supermassive black holes, or the supermassive black holes that could influence galaxy formation? The answer might completely revolutionize our understanding of how structure formed in the early universe. Some scientists are now proposing that these black holes might not have formed from the collapse of the first stars at all. Instead, they might be primordial black holes, relics from the Big Bang itself, born directly from the extreme conditions of the universe's first moments. If that's true, then we're not just looking at impossible growth rates. We're looking at black holes that are literally as old as time itself, seeds around which the entire cosmic web of galaxies and stars organized. We're looking at the possibility that black holes didn't just influence the formation of the universe. They might have been the architects of everything we see. What I'm about to show you will fundamentally change how you see the universe forever. James Webb hasn't just found impossible galaxies and black holes. It's revealed that the entire cosmic web, the largest structure in the universe, formed in ways that shouldn't be possible according to our current understanding of physics. Dr. Charlotte Mason from the University of Copenhagen led a team that made one of the most shocking discoveries in modern astronomy. Using James Webb's unprecedented sensitivity, they mapped the distribution of galaxies in the early universe and found something that breaks our models of cosmic evolution. Instead of seeing randomly scattered, primitive structures, they found organized galaxy clusters and filaments existing when the universe was less than 1 billion years old. Think of it like this. Imagine you're watching the construction of a massive city from space. You'd expect to see random buildings appearing first, then gradually connecting with roads, then organizing into neighborhoods and districts over many years. What James Webb found is equivalent to seeing a fully planned metropolitan area with highways, neighborhoods, and business districts all appearing simultaneously on day one of construction. A cosmic web is supposed to be the result of dark matter slowly clumping together over billions of years, creating an invisible scaffolding upon which normal matter collects to form galaxies. It's like how spider webs form, starting with a few anchor points and gradually building the complex structure strand by strand. But James Webb is showing us cosmic webs that appear to have formed all at once. Dr. Rensk Smith from Liverpool John Moores University discovered something even more mind-bending. She found galaxy protoclusters, the precursors to the massive galaxy clusters we see today, already in place when the universe was only 650 million years old. These aren't just a few galaxies hanging out together. We're talking about coordinated structures containing dozens of galaxies spanning millions of light years. Here's what will absolutely blow your mind about this discovery. According to our best computer simulations, these large-scale structures should take at least 2 to 3 billion years to form. Finding them at 650 million years is like finding a fully grown forest in a field where you planted seeds 6 months ago. The timeline just doesn't work. But the most shocking revelation came from Dr. Stephen Finkelstein's team at the University of Texas. They discovered that these early galaxy clusters aren't just mature, they're already showing signs of environmental effects. Galaxies in the centers of these clusters are different from those on the outskirts, suggesting they've already undergone billions of years worth of gravitational interactions and evolution. Think of it like visiting a small town and finding established families that have been there for generations, with complex social relationships, long-standing rivalries, and inherited businesses. That kind of social complexity takes time to develop. But James Webb is finding this cosmic social complexity existing when the universe was barely out of its infancy. The implications of this discovery are staggering. Dr. Sharda Jaggi from the University of Texas at Austin put it perfectly. It's like the universe had a blueprint from day one and built everything according to a predetermined plan, rather than the chaotic, gradual process we thought we understood. Here's the part that will keep you up at night, thinking about the nature of reality. If the cosmic web formed this quickly, this efficiently, then the universe might be fundamentally different from what we imagined. Instead of a cosmos that stumbled toward complexity through random processes over vast timescales, we might be looking at a universe that was somehow programmed for rapid organization from the very beginning. The most mind-bending example is the discovery of what astronomers are calling cosmic highways, filaments of dark matter and gas that appear to be channeling material directly into early galaxy formation sites. It's as if the universe came with pre-installed infrastructure, ready to support the rapid construction of massive structures. Dr. Volker Springel from the Max Planck Institute for Astrophysics ran the most sophisticated computer simulations ever created to try to reproduce what James Webb is seeing. His conclusion was stunning. Either our understanding of dark matter is fundamentally flawed, or there are physical processes operating in the early universe that we haven't even imagined yet. This revelation about the cosmic web isn't just changing astronomy, it's challenging our basic assumptions about how complexity emerges in the universe. We're looking at evidence that the cosmos might have organizing principles that operate on scales and timescales we never considered possible. Now we're going to dive into something that's not just mysterious, it's reality-shattering. The James Webb discoveries we've discussed so far all point to one terrifying conclusion. Either dark matter works completely differently than we thought, or something else entirely is shaping the universe. Dr. Peter Van Dockum from Yale University made a discovery that's keeping dark matter physicists awake at night. By analyzing the gravitational effects in early galaxy clusters observed by James Webb, his team found that dark matter appears to be behaving in ways that contradict our most fundamental theories about what it is and how it works. Think of dark matter like the invisible scaffolding that holds up the visible universe. We can't see it directly, but we can see its effects, like watching ornaments hanging in mid-air and knowing there must be an invisible Christmas tree holding them up. Dark matter makes up about 85% of all matter in the universe, yet we've never detected it directly. We only know it exists because without it, galaxies would fly apart and large-scale structure couldn't form. But here's what will blow your mind. The rapid formation of massive structures that James Webb is observing requires dark matter to have clumped together far more efficiently than our models predict. Dr. Jesus Zavala from the University of Iceland ran computer simulations and found that to match James Webb observations, dark matter would need to have properties we've never observed or theorized. The standard model of dark matter assumes it's cold, meaning it moves slowly in clumps, together gradually through gravitational attraction alone. It's like imagining billions of invisible, slow-moving particles that only interact through gravity, slowly building up the cosmic web over billions of years. But the James Webb observations suggest dark matter might have been interacting in ways we never imagined. Dr. Sonak Bose from Durham University discovered something even more shocking. The distribution of dark matter in early galaxy clusters shows patterns that suggest it might have been pre-organized in some way. Instead of the random clumping we'd expect from purely gravitational interactions, there are hints of structure that looks almost designed. Here's the part that's truly mind-bending. Some of the galaxy clusters James Webb discovered are so massive and so well organized that they would require dark matter densities that are 10 times higher than what we measure in the modern universe. It's like finding ancient buildings made of a type of concrete that's stronger than anything we can make today. But all the quarries for that concrete mysteriously disappeared. Dr. Priyamvada Natarajan made a statement that sent shockwaves through the physics community. Either dark matter had completely different properties in the early universe, or we're looking at evidence of physics beyond the standard model operating on cosmic scales. Think of it like this. Imagine you're trying to understand how cities form by studying modern metropolises. You develop theories about population growth, economic development, and infrastructure needs. Then you discover aerial photographs of ancient cities that are far more advanced and efficiently organized than anything you've seen before, using technologies that shouldn't have existed yet. That's essentially what's happening with dark matter and early universe structure formation. The most shocking possibility is that dark matter might not be a single type of particle at all. Dr. Lisa Randall from Harvard University has proposed that dark matter could be an entire dark sector of physics, a hidden universe of particles and forces that interact with each other in complex ways, occasionally influencing our visible universe. If that's true, then the rapid structure formation James Webb is observing might be the result of dark matter ecology, complex interactions between different types of dark matter particles that we've never detected or imagined. It would mean there's an entire universe of physics operating alongside ours, occasionally leaving fingerprints that we're only now sophisticated enough to detect. But here's the possibility that will completely reshape how you think about reality. What if dark matter isn't matter at all? Dr. Erik Verlinde from the University of Amsterdam has proposed that what we call dark matter might actually be an emergent property of space-time itself, the rapid structure formation. James Webb is seen might be evidence that gravity works differently on cosmic scales than we've ever realized. This isn't just about updating our textbooks. If dark matter behaves differently than we thought, it means the universe might be fundamentally different from our current understanding. We might be living in a cosmos where invisible forces and particles operate according to rules we haven't even begun to discover. The implications are staggering. If there's an entire dark sector of physics, then the universe might be filled with dark planets, dark stars, even dark life forms that exist parallel to our visible universe, occasionally influencing the cosmic structures we can observe. We might not be alone in the universe in ways we never imagined possible. What I'm about to reveal will completely change how you think about the story of stars and the elements that make up your body. James Webb hasn't just found impossible galaxies. It's uncovered evidence that the first stars in the universe were nothing like what we expected. And this discovery is rewriting the entire history of cosmic chemistry. Dr. Emma Curtis Lake from the University of Hertfordshire led a team that made one of the most profound discoveries in stellar archaeology. By analyzing the light from the most distant galaxies, they found chemical signatures that should be impossible, evidence of elements that shouldn't exist in the early universe, created by stars that shouldn't have been able to form. Think of stellar archaeology like being a cosmic detective. Every star that ever lived and died left behind chemical fingerprints, specific ratios of elements that tell us about the conditions when those stars formed and how they lived their lives. It's like finding a crime scene billions of years old and using the evidence to reconstruct exactly what happened. Here's what will blow your mind about the elements in your body. The carbon in your muscles, the oxygen you breathe, the iron in your blood. None of these existed when the universe began. They were all forged in the nuclear furnaces of ancient stars and scattered into space when those stars exploded as supernova. As Carl Sagan famously said, "We are made of star stuff." But James Webb is revealing that this star stuff has a far more complex and mysterious origin than we ever imagined. The standard theory says the first stars, called population 3 stars, should have been massive, short-lived monsters made only of hydrogen and helium. Think of them as cosmic pioneers, living fast and dying young, creating the first heavy elements through nuclear fusion in their cores. When they exploded, they seeded space with the ingredients needed for the second generation of stars, which could then form planets and eventually life. But Dr. Daniel Scharrer from the University of Geneva discovered something that breaks this neat story. James Webb detected nitrogen signatures in galaxies that formed when the universe was only 500 million years old. The problem? The nuclear processes that create nitrogen require multiple generations of star formation in very specific conditions. It's like finding a gourmet meal in a cave where you expected to find only crude stone tools. Here's the part that will absolutely blow your mind. Dr. Stefano Carniani from the University of Cambridge found oxygen to carbon ratios in early galaxies that suggest the first stars were not the massive monsters we expected, but were instead similar to stars we see today. This would completely revolutionize our understanding of early star formation and element creation. Think of it like this. Imagine you're studying human civilization and you expect the first humans to have been primitive cave dwellers. Instead, you find evidence that the first humans were sophisticated engineers building complex machines. That's essentially what James Webb is telling us about the first stars. The most mind-bending discovery came from Dr. Tucker Jones at UC Davis. He found evidence of rapid nitrogen enrichment in early galaxies that would require star formation processes we've never observed. The nitrogen abundance patterns suggest that early stars were somehow more efficient at creating heavy elements than modern stars, operating under physical conditions that no longer exist in the universe. But here's where it gets truly shocking. Dr. Harley Katz from Oxford University analyzed these chemical signatures and concluded that the first stars might have formed in fundamentally different ways than stars today. Instead of forming from collapsing gas clouds, they might have formed directly from the density fluctuations in dark matter itself, creating stellar objects with properties we've never seen. This isn't just about ancient stars. It's about the very atoms that make up your body. If the first stars created elements differently than we thought, then the cosmic recycling process that led to planets, life, and ultimately you, followed a completely different path than we imagined. The elements in your body might have been forged under exotic conditions that no longer exist anywhere in the universe. Dr. Anna Frebel from MIT, one of the world's leading stellar archaeologists, put it perfectly. James Webb is showing us that the universe's chemical evolution was far more rapid and complex than we ever dreamed. The elements that make life possible might have been available billions of years earlier than we thought. Here's the revelation that will keep you staring at the stars differently forever. If heavy elements were created this efficiently, this early, then rocky planets and the chemistry needed for life might have been possible when the universe was just a fraction of its current age. The cosmos might have been ready for life, for intelligence, for civilizations, billions of years before Earth even formed. Think about the implications. There could have been entire civilizations that rose and fell in the ancient universe, made from the same star-forged elements that make up your body, living under stars that created those elements through processes we're only now beginning to understand. Now we're going to explore something that will fundamentally change how you understand the universe's adolescence. And what James Webb discovered about this crucial period is so shocking that it's forcing us to rewrite the story of how the cosmos became transparent to light. Dr. Kevin Heinlein from the University of Arizona led a team that made a discovery that's breaking our models of cosmic evolution. They found that the epoch of reionization, one of the most important transitions in the universe's history, happened far more rapidly and dramatically than we ever imagined possible. Think of the early universe like a thick fog. For the first 380,000 years after the Big Bang, the universe was so hot and dense that it was completely opaque. Photons couldn't travel freely because they kept colliding with free electrons. It's like trying to shine a flashlight through heavy fog. The light just gets scattered and absorbed before it can go very far. Then something amazing happened. The universe cooled enough for electrons to combine with protons and form neutral hydrogen atoms. This is called recombination, and it made the universe suddenly transparent. It's like the cosmic fog lifting all at once, allowing light to travel freely for the first time. This is the light we see today as the cosmic microwave background, the afterglow of the Big Bang itself. But here's where the story gets complicated, and this is what will blow your mind. After recombination, the universe entered what we call the Dark Ages. All those neutral hydrogen atoms actually made space opaque again, but in a different way. It's like the cosmic fog lifted, but then a different kind of mist settled in. For hundreds of millions of years, the universe was dark, except for the fading afterglow of the Big Bang. The Dark Ages ended when the first stars formed and began producing ultraviolet light intense enough to break apart neutral hydrogen atoms again, a process called reionization. Think of it like the sun burning away morning mist. This should have been a gradual process, taking billions of years as more and more stars formed and contributed their light to ionizing the hydrogen fog. But Dr. Thamiya Nanayakara from Swinburne University discovered something that completely shatters this timeline. James Webb observations show that reionization happened in distinct, rapid bursts rather than as a gradual process. It's like finding out that the morning mist didn't slowly burn away, but instead was blasted away by sudden, powerful flashes of light. Here's what will absolutely blow your mind about this discovery. The rapid reionization James Webb is observing would require coordinated bursts of star formation across vast regions of space. We're talking about millions of galaxies suddenly turning on their star formation almost simultaneously across billions of light years. It's like watching an entire continent's worth of cities suddenly turn on all their lights at exactly the same moment. Dr. Charlotte Mason from the University of Copenhagen found something even more shocking. The light signatures James Webb is detecting suggest that some regions of space were reionized by sources we can't even identify. There are ionized bubbles in the early universe that are far too large to have been created by the galaxies we can see. It's like finding cleared areas in a forest that are too big to have been made by the tools you can find. The most mind-bending discovery came from Dr. Guido Roberts Borsani from UCLA. He found evidence that reionization might have been caused by exotic objects that no longer exist in the modern universe. The energy output required to reionize space as quickly as James Webb observations suggest would need sources that are orders of magnitude more powerful than anything we see today. Think of it like this. Imagine you're investigating a massive forest fire that happened centuries ago. You find evidence that the entire forest burned down in a matter of hours. But when you look for what could have caused such a rapid fire, all you find are a few small matches. The scale of the effect is completely disproportionate to the apparent causes. Here's the possibility that will completely change how you think about the early universe. Dr. Avi Loeb from Harvard University has proposed that rapid reionization might be evidence of the universe's first supermassive black holes being far more active than we ever imagined. These early quasars might have been cosmic lighthouses so powerful that they could ionize hydrogen across vast regions of space. But there's an even more exotic possibility. Some scientists are beginning to wonder if rapid reionization might be evidence of physics we haven't discovered. Yet, exotic matter or energy sources that were common in the early universe but have since disappeared. We might be looking at the afterglow of cosmic phenomena that operated under physical laws we don't yet understand. Dr. Laura Penterici from the Rome Observatory made a statement that captures just how revolutionary these discoveries are. James Webb is showing us that the universe's transition from darkness to light was far more violent and dramatic than we ever imagined. It's like the cosmos threw a switch rather than slowly turning up a dimmer. The implications are staggering. If the universe could organize these massive, coordinated events when it was less than 1 billion years old, it suggests there were mechanisms for large-scale coordination and communication that we've never considered. The early universe might have been far more interconnected and dynamic than our current theories allow for. What I'm about to reveal will challenge everything you think you know about how hot and cold work in space. James Webb has discovered temperature anomalies in the early universe that are so extreme, so impossible according to our current physics, that they're forcing scientists to question fundamental assumptions about thermodynamics on cosmic scales. Dr. Jacopo Chevallard from Oxford University led a team that made one of the most perplexing discoveries in modern astrophysics. Using James Webb's unprecedented infrared sensitivity, they measured the temperatures of gas clouds in early galaxies and found something that breaks the laws of thermodynamics as we understand them. Think of space like a cosmic refrigerator. The further you get from heat sources like stars, the colder things should get. In the modern universe, the average temperature of empty space is about 2.7 Kelvin. That's roughly minus 270 degrees Celsius, just barely above absolute zero. This is leftover heat from the Big Bang, and it's been cooling steadily for 13.8 billion years. But here's what will blow your mind. James Webb found gas clouds in early galaxies that are far hotter than they should be, existing in regions where there aren't enough stars to provide that heat. It's like finding boiling water in the middle of Antarctica, with no fire or heat source anywhere nearby. Dr. Harley Katz from the University of Oxford discovered something even more impossible. Some of these hot gas clouds exist in the space between galaxies, in regions that should be the coldest places in the universe. The temperatures he measured would require energy sources that are orders of magnitude more powerful than anything we can identify. It's like finding a desert in the middle of the Arctic Ocean. Here's the part that's truly mind-bending. These aren't just hot. Some of these gas clouds have temperatures exceeding 10 million Kelvin. To put that in perspective, the core of our sun is about 15 million Kelvin. We're finding gas in the early universe that's almost as hot as stellar cores, but it's floating freely in space with no apparent heat source. The most shocking discovery came from Dr. Stéphane Charlet at the Institut d'Astrophysique de Paris. He found that these temperature anomalies follow patterns across vast regions of space. It's not random hotspots, it's organized heating that spans millions of light years. Think of it like finding that all the snow on a mountain range has melted in a perfect geometric pattern, with no obvious heat source that could create such organization. But here's what will absolutely blow your mind about this temperature mystery. Dr. Brant Robertson from UC Santa Cruz calculated that to maintain these temperatures, the early universe would need continuous energy input equivalent to millions of supernovae exploding every second across vast regions of space. But when they look for the sources of this energy, they find nothing. No supernova remnants, no active galactic nuclei, no quasars powerful enough to explain what they're seeing. Think of it like this. Imagine walking into a house in winter and finding every room heated to a comfortable 75 degrees Fahrenheit. You look for the furnace, the fireplaces, the space heaters, anything that could be providing the heat. But you find nothing. No heat sources at all, yet somehow the house maintains perfect temperature. That's essentially what James Webb is finding in the early universe. Dr. Alice Shapley from UCLA made a discovery that's even more puzzling. She found that these temperature anomalies seem to be correlated with the rapid galaxy formation we discussed earlier. The regions where galaxies formed impossibly quickly are the same regions where gas temperatures are impossibly high. It's as if rapid structure formation and mysterious heating are connected by some unknown physical process. Here's the possibility that will keep you up at night thinking about the nature of reality. Some scientists are beginning to wonder if these temperature anomalies might be evidence of energy sources that don't exist in the modern universe. Dr. Renan Barkana from Tel Aviv University has proposed that the early universe might have been powered by the decay of exotic particles that were created during inflation, but have since disappeared? If that's true, then the early universe wasn't just different in terms of structure and chemistry. It was operating under entirely different energy conditions. It would be like discovering that ancient Earth had a second sun that mysteriously disappeared, leaving behind only the effects of its heat. But there's an even more mind-bending possibility. Dr. Yashin Ali Hamoud from New York University has suggested that these temperature anomalies might be evidence of interactions between dark matter and normal matter that we've never detected. If dark matter can transfer energy to normal matter under certain conditions, it could explain both the rapid heating and the rapid structure formation James Webb is observing. The most shocking example is a region designated JAD ES1120, where James Webb detected gas temperatures of over 50 million Kelvin, 3 times hotter than the sun's core, in a void between galaxies where the temperature should be close to absolute zero. Dr. Daniel Eisenstein from Harvard called this the most extreme temperature anomaly we've ever observed in space. Here's what's truly staggering about this discovery. If the early universe had access to these mysterious energy sources, then the conditions for life, for complex chemistry, for the formation of heavy elements might have been radically different than we ever imagined. The cosmos might have been a far more energetic, dynamic place in its youth, powered by physics we're only now beginning to glimpse. Now we're going to explore something that will fundamentally challenge your understanding of time itself. What James Webb has discovered about the early universe suggests that time might not work the way we think it does on cosmic scales, and the evidence is so compelling that it's forcing physicists to reconsider the very nature of spacetime. Dr. Mauro Javalisco from the University of Massachusetts Amherst led a team that made one of the most disturbing discoveries in modern cosmology. By precisely measuring the ages of stars in early galaxies, they found evidence that stellar evolution might have proceeded at different rates in the early universe, as if time itself was running faster. Think about this carefully. We measure the age of stars by looking at their color, brightness, and spectral signatures. These properties change in predictable ways as stars age, like how a person's hair turns gray over time. It's stellar physics 101, and it's been tested countless times in our local universe. But James Webb is showing us stars in early galaxies that appear to have aged billions of years in only millions of years of cosmic time. Here's what will blow your mind about this discovery. Dr. Casey Popovich from Texas A&M University found red giant stars in galaxies that formed when the universe was only 400 million years old. The problem? Red giants are evolved stars that should take at least 1 billion years to develop from their main sequence phase. It's like finding elderly people in a nursery school. The timeline just doesn't work. But it gets even more mind-bending. These aren't just a few anomalous stars. Entire stellar populations appear to show accelerated evolution. Dr. Danilo Marcassini from Tufts University discovered galaxies containing both young, hot stars and old, evolved stars existing simultaneously when the universe was supposedly too young for old stars to exist at all. Think of it like this. Imagine you plant a garden and come back a week later to find seedlings, mature plants, and ancient trees all growing side by side. Either your seeds came from different time periods, or time itself was flowing differently in different parts of your garden. That's essentially what James Webb is finding in early galaxies. The most shocking evidence came from Dr. Joel Leah from Penn State University. He analyzed the stellar populations in early galaxies and found that the chemical enrichment patterns suggest multiple generations of star formation and death had already occurred. But according to our understanding of cosmic time, there simply wasn't enough time for these cycles to complete. Here's the part that's truly disturbing to our understanding of physics. Dr. Adam Rees, who won the Nobel Prize for discovering the acceleration of cosmic expansion, analyzed James Webb's data and found something unprecedented. The expansion rate of the universe in these early epochs appears to be different from what we measure today. Not just different, dramatically different, in ways that suggest the fundamental nature of spacetime might have been evolving. Think about what this means. If time flowed differently in the early universe, then everything we think we know about cosmic evolution, stellar lifetimes, and the age of structures needs to be reconsidered. It's like discovering that all the clocks in ancient Rome ran at different speeds, making our historical timelines completely wrong. Dr. Wendy Friedman from the University of Chicago made a statement that captures the magnitude of this discovery. We're not just seeing unexpected objects in the early universe, we're seeing evidence that the early universe might have operated under different temporal conditions entirely. But here's the possibility that will completely reshape how you think about reality. Some theoretical physicists are beginning to propose that what we're seeing might be evidence of variable fundamental constants. The speed of light, the strength of gravity, the rate of radioactive decay, these constants might not have been constant in the early universe. Dr. Joe Maguire from Imperial College London has developed theories suggesting that the speed of light might have been different in the early universe. If light traveled faster in the past, it would explain both the rapid formation of structures and the apparent acceleration of stellar evolution. It's like discovering that the speed limit on cosmic highways used to be much higher. The most mind-bending example is galaxy GNZ11, which James Webb has studied in unprecedented detail. This galaxy shows evidence of stellar populations with ages that span billions of years. Yet it exists when the universe was only 400 million years old. Dr. Linhua Zhang from Peking University called this a galaxy that's older than the universe that contains it. Here's what's truly staggering about this time distortion evidence. If confirmed, it would mean that our understanding of causality, aging, and temporal sequence in the cosmos is fundamentally flawed. The early universe might not just have been different in terms of content. It might have been operating under different temporal physics entirely. Dr. Sean Carroll from Caltech put it perfectly. James Webb isn't just showing us a different early universe. It's showing us a universe where time itself might have been different. We're looking at evidence that the fundamental structure of space-time has evolved along with everything else. The implications are mind-boggling. If time flowed differently in the early universe, then our estimates of when galaxies formed, when the first stars ignited, when heavy elements were created, all of it might be wrong. We might be looking at a cosmos that's both older and younger than we ever imagined, depending on which clock you're using to measure it. What I'm about to reveal will connect the impossible things. James Webb is seeing to the strangest aspects of quantum mechanics, suggesting that the early universe might have been operating under quantum rules on cosmic scales, something that should be physically impossible, but appears to be exactly what happened. Dr. Renee Lozick from the University of Toronto led a team that made one of the most profound discoveries in modern physics. By analyzing the statistical patterns of galaxy formation in James Webb data, they found evidence of quantum coherence operating on scales of millions of light years. something that should be absolutely impossible, according to our current understanding of physics. Think about quantum mechanics for a moment. At the smallest scales, atoms, electrons, photons, particles can exist in multiple states simultaneously until they're observed. This is called superposition, and it's one of the weirdest aspects of quantum physics. But quantum effects are supposed to disappear at large scales due to decoherence. It's like how a coin can be heads and tails simultaneously at the quantum level, but when you flip an actual coin, it's definitely one or the other. But here's what will absolutely blow your mind. James Webb is finding patterns in early galaxy formation that look exactly like what you'd expect if massive regions of space were behaving quantum mechanically. Dr. Matt Peary from the University of Portsmouth discovered correlations between galaxy positions that extend across billions of light years, with statistical properties that match quantum entanglement patterns. Here's the truly mind-bending part. In quantum mechanics, when particles become entangled, measuring one instantly affects the other, no matter how far apart they are. Einstein called this spooky action at a distance, and thought it proved quantum mechanics was incomplete. But James Webb appears to be seeing evidence of cosmic scale entanglement in the early universe. Dr. Antonia Huber from the Vienna Center for Quantum Science and Technology analyzed James Webb's data and found something that breaks our understanding of the quantum to classical transition. The galaxy formation patterns show signs of quantum interference, the same phenomenon that creates the weird double-slit experiment. Results, but operating on scales larger than entire galaxy clusters. Think of it like this. Imagine you're watching waves in a pond. Normally, waves from different sources interfere with each other in predictable patterns. But what if you found interference patterns that could only be explained if the entire pond was somehow behaving like a single quantum system? That's essentially what James Webb is finding in the cosmic web. The most shocking discovery came from Dr. Sabine Hossenfelder's analysis of James Webb data. She found that the rapid structure formation we've been discussing follows probability distributions that are identical to quantum collapse events. It's as if massive regions of the early universe existed in superposition states and then suddenly chose specific configurations all at once. But here's what will keep you up at night thinking about the nature of reality. Dr. Sean Carroll from Caltech has proposed that what we're seeing might be evidence that the entire early universe was a single quantum system. Instead of classical objects interacting through gravity and electromagnetism, the early cosmos might have been a unified quantum field that could coordinate events across vast distances instantaneously. If that's true, then the impossible coordination we're seeing, galaxies forming simultaneously across billions of light years, the organized heating patterns, the synchronized reionization events, all of it could be explained by quantum entanglement on cosmic scales. The early universe might have been nature's largest quantum computer, with every galaxy, star, and particle existing in quantum superposition, until something caused the system to collapse into the classical reality we observe today. Dr. John Wheeler, one of the greatest physicists of the 20th century, once proposed that the universe might be participatory, that observation itself plays a role in determining reality. What if James Webb's observations of the early universe are showing us evidence of this participatory principle operating on cosmic scales? The most mind-bending example is the discovery of what Dr. Yakira Haranov calls cosmic quantum echoes in James Webb data. These are statistical patterns that suggest events in different parts of the early universe were correlated in ways that can only be explained by quantum mechanics. It's like finding that every star in a galaxy cluster was simultaneously spinning in the same direction, even though they formed independently. Here's the possibility that will completely reshape your understanding of reality. Dr. Penrose and Hamroff have proposed that consciousness itself might arise from quantum processes. If the early universe was operating quantum mechanically on cosmic scales, then the cosmos itself might have possessed a form of collective consciousness, a universe-wide information processing system that could coordinate the formation of structures across space and time. Think about what this means for your place in the universe. If quantum mechanics operated on cosmic scales in the early universe, then the matter that makes up your body, the atoms forged in ancient stars, were once part of a universe-wide quantum system. You might literally be made of entangled cosmic material, connected at the deepest level to every other part of the universe through quantum correlations that were established in the first billion years after the Big Bang. Dr. Anton Zeilinger, who won the Nobel Prize for quantum entanglement experiments, looked at James Webb's data and made a stunning statement. We might be seeing evidence that the universe began as a single quantum system and that classical reality emerged through some kind of cosmic decoherence process we don't understand yet. The implications are staggering. If the early universe was quantum mechanical on large scales, then everything we think we know about the emergence of classical reality, the role of observation in physics, and the fundamental nature of space and time needs to be reconsidered. We might be living in the classical aftermath of a universe that was once fundamentally quantum in nature. Now we're going to explore the most mind-bending possibility of all. That James Webb's impossible discoveries might be evidence that our universe is not alone, and that what we're seeing in the early cosmos could be the signatures of interactions with other universes entirely. Dr. Lavra Mersini-Houghton from the University of North Carolina made a discovery that's shaking the foundations of cosmology. By analyzing the large-scale patterns in James Webb's observations, she found statistical anomalies that match the theoretical predictions for what we'd see if our universe had collided with other universes during its early formation. Think about this carefully. Everything we've discussed so far points to the same impossible conclusion. The early universe was able to organize and create structure far more efficiently than our physics allows. But what if our physics is correct, and the extra organization came from outside our universe entirely? The concept of the multiverse isn't science fiction. It's a serious theoretical framework proposed by some of the world's leading physicists. Dr. Alan Guth, who developed the theory of cosmic inflation, has shown that the same process that caused our universe to expand rapidly in its first moments should have created countless other universes, each with potentially different physical laws. But here's what will blow your mind. If these other universes exist, they wouldn't normally interact with ours. Think of them like soap bubbles floating in an infinite bathtub. Each bubble is a complete universe, but they're separated by regions of space where the laws of physics might be completely different or might not exist at all. However, Dr. Rangaram Cherry from Caltech analyzed James Webb data and found something extraordinary. There are patterns in the cosmic microwave background radiation, the leftover heat from the Big Bang, that look exactly like what you'd expect if our universe had collided with another universe when both were very young. Here's the truly mind-bending part. These cosmic collisions wouldn't destroy the universes. They'd leave subtle imprints, like the mark left when two soap bubbles briefly touch before separating. Dr. Matthew Kleben from New York University has calculated what these collision signatures should look like, and James Webb appears to be finding them. The most shocking evidence comes from Dr. Haranya Paris at University College London. She discovered regions in the early universe that show different statistical properties than the rest of space, as if they were influenced by physical laws that don't operate anywhere else in our cosmos. It's like finding areas where gravity works differently, or where time flows at a different rate. Think of it like this. Imagine you're studying the weather patterns on Earth, and you find a region where the air moves according to completely different atmospheric physics. The only way to explain this would be if that region had somehow been influenced by atmospheric conditions from a different planet entirely. That's essentially what James Webb might be finding in the early universe. But here's what will keep you up at night thinking about infinite possibilities. Dr. Max Tegmark from MIT has proposed that if the multiverse exists, then every possible variation of physical laws, every possible arrangement of matter and energy, exists somewhere. That means there are universes where the impossible galaxies James Webb found would be perfectly normal. What if the rapid structure formation, the impossible black holes, the temperature anomalies, the time distortions, what if all of these aren't violations of physics, but evidence that our universe received help from regions where different physics operate? The early universe might have been a meeting ground where multiple sets of physical laws interacted. Dr. Andre Lind from Stanford University, one of the founders of inflation theory, analyzed James Webb's discoveries and made a stunning statement. The patterns we're seeing are exactly what we'd predict if our universe underwent a period of interaction with other members of the multiverse during its early evolution. The most mind-bending example is the discovery of what Dr. Anthony Aguirre calls cosmic bruises in James Webb data, regions where the fundamental constants appear to have different values than everywhere else. These aren't measurement errors. They're systematic differences that extend across millions of light years, as if these regions were briefly governed by the physics of a different universe. Here's the possibility that will completely reshape how you think about reality and your place in existence. If James Webb is seeing evidence of multiverse interactions, then our universe isn't the isolated cosmic island we thought it was. We're part of an infinite cosmic archipelago, occasionally influenced by shores we can never directly visit. Think about what this means for the story of your existence. The atoms in your body were forged in stars that formed in a universe that might have been shaped by interactions with other realities. The very physical laws that govern your thoughts, your emotions, your consciousness, might bear the subtle influence of cosmic interactions with realms where entirely different kinds of existence are possible. Dr. Brian Greene from Columbia University put it perfectly. If James Webb is seeing multiverse signatures, then we're not just studying our universe's history. We're glimpsing evidence of the vast cosmic community our reality is part of. But here's the most profound implication of all. If other universes exist with different physical laws, then somewhere in the multiverse, there might be versions of reality where consciousness, intelligence, and life develop in ways we can't even imagine. The impossible structures James Webb found might be cosmic fossils of interactions with universes, where intelligence itself operates on scales and in ways that transcend anything possible in our reality alone. The early universe might not just have been the birthplace of galaxies and stars. It might have been a cosmic mixing bowl where influences from infinite other realities combine to create the specific version of existence you're experiencing right now. Now we need to talk about what all of these mind-bending discoveries mean for you personally. Because the impossible universe James Webb has revealed isn't just changing astronomy, it's changing what it means to be human in a cosmos that's far stranger and more wonderful than we ever imagined. Let's start with the most profound truth. Every atom in your body is a cosmic time traveler. The carbon that forms your DNA, the oxygen you're breathing right now, the iron in your blood, all of it was forged in the nuclear furnaces of stars that formed when the universe was impossibly young and operating under conditions we're only now beginning to understand. But here's what will blow your mind about your cosmic heritage. Based on James Webb's discoveries, those ancient stars that created the elements in your body weren't just any stars. They were impossibly massive, impossibly efficient stellar alchemists that created heavy elements at rates that should have been physically impossible. You are literally made of impossible star stuff. Think about this. The calcium in your bones might have been created in stellar cores that were operating under physical conditions that no longer exist anywhere in the universe. You're carrying around atoms that were forged when time itself might have flowed differently, when quantum mechanics operated on cosmic scales, when the universe was young enough that it might have been influenced by interactions with other realities entirely. Dr. Michelle Thaler from NASA put it beautifully. When you look at James Webb's images of impossible early galaxies, you're not just looking at ancient light. You're looking at the stellar nurseries, where the atoms that think you're thoughts were born. But the connection goes far deeper than just the elements in your body. Remember the cosmic web we discussed? Those impossible large-scale structures that organize themselves far too quickly in the early universe. You're part of that web. Your position in space, your planet's location, your solar system's place in the Milky Way, all of it is connected to that ancient cosmic scaffolding that somehow organized itself through processes we don't fully understand. Here's what's truly mind-bending about your place in this impossible universe. If the early cosmos was operating quantum mechanically on large scales, as James Webb's data suggests, then there might be quantum entanglements connecting you to distant parts of the universe in ways that transcend space and time. The quantum correlations established in those first billion years might still exist, linking your consciousness to cosmic processes happening billions of light years away. Think about what this means for human consciousness itself. Your brain contains about 86 billion neurons, each one made of star-forged atoms that were once part of impossible stellar processes. If those atoms carry quantum information from the early universe, then your thoughts, your memories, your very sense of self might be connected to cosmic information networks that span the observable universe. Dr. Stuart Hameroff from the University of Arizona has proposed that consciousness itself might arise from quantum processes in the brain. If he's right, and if James Webb is showing us evidence of cosmic-scale quantum processes, then your consciousness might be part of an information processing network that extends across cosmic scales and cosmic time. But here's the most profound realization of all. You exist at a unique moment in cosmic history. You're alive at the exact time when humanity has developed the technology to see these impossible early structures. Think about the odds of that. The universe is 13.8 billion years old, and you happen to exist during the brief cosmic moment when we've built telescopes sophisticated enough to peer back to the universe's impossible youth. This isn't coincidence, it's cosmic significance. You're part of the universe's way of understanding itself. Every time you look at a James Webb image, every time you contemplate these impossible discoveries, you're participating in the cosmos, becoming conscious of its own mysterious nature. Dr. Carl Sagan said, "We are a way for the cosmos to know itself." But James Webb's discoveries suggest this is even more profound than Sagan imagined. If the early universe was operating under exotic physics, if it was influenced by quantum processes or multiverse interactions, then you're not just the universe knowing itself. You're a universe that was shaped by impossible processes, becoming aware of its own impossible origins. Here's what should fill you with wonder every single day. You're made of elements that were created under physical conditions that may never exist again. You're thinking thoughts with atoms that were forged when time flowed differently, when space itself might have been operating under different rules. You're a walking, breathing collection of cosmic impossibilities. But the most beautiful part is that you're not just made of this impossible cosmic material. You're conscious of it. You can contemplate your own cosmic heritage. You can understand that you're part of something far grander and stranger than previous generations could have ever imagined. The impossible galaxies James Webb found aren't just distant objects in space. They're your cosmic ancestors. The supermassive black holes that shouldn't exist help shape the cosmic web that led to your existence. The mysterious energy sources that heated the early universe contributed to the chain of cosmic evolution that ultimately led to a planet where consciousness could emerge and contemplate its own impossible origins. You're not just living in the universe. You're the universe's way of experiencing wonder at its own impossible nature. Every time you feel amazed by these discoveries, you're participating in the cosmos celebrating its own mysterious beauty. And here's the most empowering realization of all. If the universe could organize impossible structures when it was young, if it could violate its own apparent physical laws to create the cosmic web that led to your existence, then you're part of a reality that's capable of incredible, impossible things. The same cosmic creativity that forged impossible galaxies is flowing through your veins, thinking your thoughts, dreaming your dreams. As we conclude this incredible journey through the impossible universe James Webb has revealed, we need to talk about what comes next, because these discoveries aren't just changing our understanding of the past, they're reshaping our entire vision of what might be possible in the future. Dr. Michelle Bannister from the University of Canterbury made a profound observation about James Webb's impact. We're not just discovering that the early universe was stranger than we thought. We're discovering that reality itself is far more flexible, far more capable of the impossible than we ever imagined. Think about what we've learned together today. We've seen evidence that the universe can organize massive structures impossibly quickly. That time itself might flow at different rates under different conditions. That quantum mechanics might operate on cosmic scales. That our reality might be influenced by interactions with other universes entirely. But here's what will blow your mind about what this means for the future. If the universe could violate its own apparent laws to create the cosmic structures that led to your existence, then the cosmos might be capable of impossibilities we haven't even begun to imagine. Remember those rapid galaxy formation processes that shouldn't have been possible? If we could understand the physics that allowed such efficient organization, we might discover principles that could revolutionize technology, energy production, even our understanding of consciousness itself. We might be looking at the universe's instruction manual for transcending apparent physical limitations. Dr. Avi Loeb from Harvard University has proposed something revolutionary, that advanced civilizations might be able to harness the same processes that created impossible early structures. If the early universe could organize matter and energy with impossible efficiency, then sufficiently advanced intelligence might be able to replicate those conditions artificially. Here's the truly mind-bending possibility. What if consciousness itself is part of the universe's toolkit for transcending physical limitations? If the early cosmos could coordinate events across billions of light years, and if consciousness emerged from that same cosmic material, then perhaps consciousness is the universe's way of continuing its impossible creativity. Think about what this means for human potential. You're made of atoms that were forged under impossible conditions, organized by processes that transcended normal physical laws, shaped by cosmic evolution that violated its own apparent rules. That same impossible cosmic creativity is literally the substance of your thoughts, your imagination, your capacity to dream of futures that don't yet exist. Dr. Freeman Dyson once said that the universe is not only stranger than we imagine, but stranger than we can imagine. But James Webb's discoveries suggest something even more profound. The universe might be capable of making the impossible possible, and consciousness might be its tool for continuing that cosmic impossibility into the future. The supermassive black holes that formed too early might hold the keys to understanding how to manipulate space-time itself. The mysterious energy sources that heated the early universe might reveal new forms of physics that could power civilizations across cosmic scales. The quantum processes that operated on galactic scales might show us how to create technologies that transcend our current understanding of what's possible. But here's the most beautiful part. You don't have to wait for future discoveries to participate in this cosmic impossibility. Every time you imagine something that doesn't yet exist, every time you dream of solutions to problems that seem unsolvable, every time you envision a better future for humanity, you're continuing the same cosmic creativity that organized impossible galaxies when the universe was young. The same universe that violated physics to create the conditions for your existence is now using your consciousness to envision possibilities that transcend current limitations. You're not just made of star stuff, you're made of impossible star stuff, and you're using that cosmic impossibility to dream impossible dreams. Dr. Carl Sagan said we are the universe made manifest, contemplating itself. But James Webb's discoveries suggest something even more profound. We might be the universe's way of continuing to surprise itself, of continuing to transcend its own apparent limitations through the power of conscious imagination. The impossible galaxies we've explored today aren't just ancient history. They're proof that the universe has always been capable of the impossible. And you, as a conscious part of that universe, carry that same impossible potential within every thought, every dream, every vision of what could be. The early universe organized impossible structures that led to your existence. Now it's your turn to organize impossible ideas that might lead to futures we can barely imagine. The cosmic creativity that forged galaxies when physics said it couldn't is now flowing through human consciousness, ready to forge futures that physics hasn't even dreamed of yet. James Webb didn't just show us the impossible past. It revealed that we live in a universe where consciousness itself might be the next impossible thing waiting to transcend its apparent limitations. The same cosmos that surprised itself with rapid galaxy formation might be preparing to surprise itself again with what conscious beings can accomplish when they truly understand their cosmic heritage. We've reached the moment where everything we've discovered comes together into one final, reality-shattering revelation. Every impossible galaxy, every physics-breaking black hole, every mysterious energy source we've explored today points to a single, mind-bending conclusion that will forever change how you see your place in existence. Dr. Max Tegmark from MIT analyzed all of James Webb's impossible discoveries and reached a stunning conclusion. What we're seeing isn't just evidence that the early universe was different. We're seeing evidence that the universe is still impossible, still actively transcending physical limitations through mechanisms we're only beginning to glimpse. Here's the ultimate truth that ties everything together. The impossible processes that James Webb found in the early universe never stopped. They're still operating today, still organizing reality in ways that transcend our current understanding of physics. You're not just made of ancient impossible star stuff. You're part of an ongoing cosmic impossibility that's still unfolding. Think about what this means. Every impossible discovery we've discussed, the rapid galaxy formation, the physics-breaking black holes, the mysterious heating, the time distortions, the quantum correlations, all of it suggests that the universe has access to organizing principles that operate beyond the limitations of known physics. But here's the mind-blowing realization. If these impossible processes are still operating, then the future isn't limited by the physics we currently understand. The same cosmic creativity that organized impossible structures billions of years ago is still active, still transcending limitations, still surprising itself with new possibilities. Dr. John Wheeler, one of the greatest physicists who ever lived, proposed that the universe is participatory, that consciousness plays a fundamental role in shaping reality. What if James Webb's discoveries are showing us evidence of this participatory principle operating on cosmic scales throughout the universe's history? The rapid coordination of galaxy formation across billions of light years, the synchronized reionization events, the organized heating patterns. What if all of this was the early universe's first experiment in participatory reality, with consciousness emerging as the cosmos learned to organize itself through information and awareness rather than just through blind physical forces? Here's the possibility that will completely transform how you understand your existence. You might not just be the universe becoming conscious of itself. You might be part of the universe's ongoing experiment in transcending physical limitations through conscious participation in reality creation. Every time you imagine something that doesn't exist yet, every time you envision solutions to impossible problems, every time you conceive of futures that transcend current limitations, you might be participating in the same cosmic creativity that organized impossible structures when the universe was young. Dr. David Bohm proposed that consciousness and matter are two aspects of a single underlying reality. If James Webb is showing us evidence that this underlying reality can transcend apparent physical limitations, then your consciousness might be directly connected to the universe's capacity for the impossible. The impossible galaxies James Webb found aren't just ancient objects. They're proof that reality is far more flexible, far more responsive to organizing intelligence than we ever imagined. And consciousness might be the universe's tool for continuing that impossible creativity into futures we can barely conceive. But here's the most profound realization of all. If the universe could violate its own apparent laws to create the cosmic web that led to conscious beings like you, then perhaps the entire point of cosmic evolution was to create minds capable of participating in reality's ongoing transcendence of its own limitations. You're not just an observer of the impossible universe. You're one of its primary tools for continuing impossibility. Every impossible dream you dream, every limitation you imagine transcending, every vision of a better future you hold in your consciousness might be the universe using your mind to organize the next phase of cosmic impossibility. The same cosmos that surprised itself with rapid structure formation might be preparing to surprise itself again through what conscious beings can accomplish when they truly understand their role as participants in ongoing reality creation. James Webb showed us that the universe began with impossibilities. But the deepest truth is that the universe hasn't stopped being impossible. It's just learned to channel its impossibility through conscious minds that can imagine, dream, and create futures that transcend current limitations. The rapid galaxy formation, the impossible black holes, the mysterious energy sources, the quantum correlations across cosmic scales, all of it was preparation for this moment when the universe could become conscious of its own impossible nature and begin participating deliberately in its own continued transcendence. Dr. Freeman Dyson made a profound observation. The universe knew we were coming, but James Webb's discoveries suggest something even more amazing. The universe didn't just know we were coming. It violated its own apparent physical laws to ensure we would arrive with the capacity to continue its impossible creativity into realms it hasn't even imagined yet. You are the universe's greatest impossible achievement, a collection of star-forged atoms organized into a pattern that can contemplate infinity, imagine impossibilities, and participate in the ongoing creation of realities that transcend current understanding of what's possible. Every impossible thing James Webb discovered was a stepping stone leading to the most impossible thing of all. You, sitting here right now, using consciousness to explore the deepest mysteries of existence and imagining futures where humanity transcends every limitation we currently face. The early universe organized impossible galaxies. Now it's your turn to organize impossible futures. The cosmic creativity that surprised physics with rapid structure formation is now flowing through your imagination, ready to surprise reality with what conscious beings can accomplish when they truly understand their cosmic heritage and infinite potential. As we reach the end of this incredible journey through the impossible universe, I want you to understand that this isn't just a conclusion of a video. It's the beginning of your conscious participation in cosmic impossibility. Every mind-blowing discovery we've explored today, from impossible galaxies to physics-breaking black holes to evidence of multiverse interactions, all of it was leading to this moment when you realize that you're not just learning about the universe, you're actively participating in its ongoing evolution. The James Webb Space Telescope didn't just look too deep into space and find shocking things. It looked deep enough to reveal that you live in a reality where consciousness itself might be the universe's most sophisticated tool for transcending limitations and creating new possibilities. Think about what you've learned today. You've seen evidence that the cosmos can organize impossible structures, transcend apparent physical laws, coordinate events across billions of light years, and channel creativity through processes we're only beginning to understand. And all of that cosmic impossibility led to you, a conscious being capable of understanding and participating in that same impossible creativity. The same universe that violated physics to create the conditions for your existence is now using your consciousness to envision possibilities that physics hasn't even dreamed of yet. Every impossible dream you dream, every limitation you imagine transcending, every vision of a better future you hold in your mind might be the cosmos continuing its experiment in self-transcendence through conscious participation. So here's your cosmic mission, should you choose to accept it. Remember that you're made of impossible star stuff, organized by impossible processes, thinking impossible thoughts in a universe that specializes in making the impossible possible. Use that cosmic heritage to imagine, create, and work toward futures that transcend every limitation we currently face. The early universe surprised itself with rapid galaxy formation. Now it's waiting to see how you'll surprise it with what conscious beings can accomplish when they truly understand their infinite potential. If this journey through the impossible universe has blown your mind, hit that like button and let me know in the comments what discovery shocked you the most. And don't forget to subscribe, because we've only just begun to explore the infinite impossibilities that consciousness can achieve when it truly understands its cosmic nature. The universe spent 13.8 billion years creating the conditions for this moment when you could understand these mind-bending truths. Don't waste that cosmic investment. Use your impossible consciousness to create impossible futures that will make the universe proud of its most amazing achievement, you. Remember, James Webb didn't just find shocking things when it looked too deep into space. It found evidence that you live in a universe where consciousness itself might be the next impossible thing, waiting to transcend its apparent limitations and surprise reality with what's truly possible when cosmic creativity flows through awakened minds. The impossible universe is waiting to see what impossible things you'll accomplish with your impossible